I hope you did your test 1 well. Today we begin Unit 2, which is the study of thermodynamics. What does thermodynamics deal with? Thermodynamics deals with the study of heat and temperature. So we begin by defining heat. Do you know what heat is? Well, heat is a form of energy. Well, you know there are many forms of energy. Now, heat is a form of energy, and when you supply heat to an object, what happens? The internal energy of that object will increase. What is the meaning of internal energy of an object? Internal energy of an object is made up of potential and kinetic energies of the atoms and molecules that make up the object. Now, you know kinetic energy is associated with the speed of motion. And you know when you supply heat to an object, the molecules will pick up speed. Is that right? Okay. How about potential energy? Potential energy is associated with relative positions of atoms and molecules. Tell me, when does this ball has maximum potential energy? You know that in order to move this ball away from the surface of the earth, I have to do work. So this ball has maximum potential energy with respect to the earth when it is very far from the earth. So if you have a system of objects, when is their potential energy maximum? Their potential energy is maximum when they are much farther apart. When they are closer together, their potential energy is the minimum. In a solid, for example, the molecules are very closely packed. That means they are held by intermolecular forces very strongly. In such a case, we say the potential energy is the least. In order to separate them, you need to do work. And this work can be done by supplying heat. So supplying heat can increase the potential energy of atoms and molecules. It can also increase the kinetic energy of atoms and molecules. In this unit, we will study about these two phenomena. Well, so let's talk about temperature and gas laws. We have a fairly good idea on what heat is. We said heat is a form of energy, and when heat is supplied to an object, it increases the internal energy of the object. We also said internal energy of an object is made up of kinetic and potential energy of its atoms and molecules. Now, atoms and molecules have kinetic energy because of their vibrational, rotational, and translational motions. You see, all kinds of motions atoms and molecules can have. And when any of these types of motion change, the kinetic energy change. And potential energy of atoms and molecules are associated with their relative states or positions. When you want to separate atoms and molecules, their potential energy increases. You know, if you want to crack a nut, what do? You place the nut on a surface and bang it. Is that right? Now, what are you actually doing? You are supplying energy so as to break the nut into pieces, and what you see are the pieces flying away from each other. The amount of energy you supplied increases the potential energy of the system in taking them apart. Now, potential energy of a system is greater when the objects are farther apart, and the potential energy is minimum when they are closer together. Alright, what is temperature? Very often these concepts are confused by students. What is the difference between temperature and heat? Can you give me a satisfactory explanation on the difference between temperature and heat? Well, when heat energy is supplied to an object, its temperature rises. But the question is, will it happen all the time? We will answer that question as we move on. Now, the rise in temperature is purely due to the increase in the translational kinetic energy of the molecules of the object. In other words, the temperature increase is purely due to the increase or decrease in kinetic energy. If a potential energy is not registered as an increase or decrease in temperature. So temperature is affected only by the translational kinetic energy. That means when the kinetic energy is maximum, the temperature will be maximum. When the kinetic energy is minimum, the temperature will also be minimum. Alright? Here I have an illustration of molecular motion. You can see the lower temperature corresponds to rather very slow motion of molecules. You can actually see molecules in a gas move at random. They hit against each other, and the molecular speeds represents the temperature. If you increase the temperature, the molecular speeds also will increase. Now, this is a slightly higher temperature. You can see the molecular speeds are greater in this case. So temperature is purely determined by molecular speed. In order to distinguish between temperature and heat, let us consider two different quantities of water, one in a small beaker and another in a big beaker. A large quantity of water and a small quantity of water are supplied heat at the same rate. Both receive heat at the same rate. Tell me, which of these will register a higher temperature? Well, I know most of you will tell me that this will register a higher temperature. Why? What is the reason? The same amount of energy is shared among less number of molecules here than in the large container. That means the share of energy per molecule is much greater in the smaller beaker. Is that right? Each molecule in the smaller beaker will now have much greater kinetic energy than the energy in the bigger beaker. So the larger quantity will have a smaller increase in temperature, while the smaller quantity will have a larger increase in temperature. Why? Because the average energy received by molecules in the smaller beaker will be greater. The energy per molecule will be greater. Can we use that to define temperature? Look at the way I have defined temperature. Temperature of an object is proportional to the average kinetic energy of its molecules. So if a substance, the molecules of a substance has average kinetic energy greater than the molecules of another substance, we would say the temperature of the first substance is greater. Temperature is proportional to the average kinetic energy of the molecules of that substance. Now look at this. I have two substances that have the same average kinetic energy but different amounts of potential energy. That means the internal energy, the total internal energy of the second object is much, much greater than the total internal energy of the first object. But because the average kinetic energy is the same in both cases. They are both of the same temperature. Temperature is determined by the average kinetic energy of the molecules. In other words, it depends on the square of the velocity. How do we measure temperature? Well, of course, we use a thermometer. Now, in order to measure temperature, we make use of properties of materials that change with temperature. Can you tell me some of the properties of materials that change with temperature? When you heat an object, what are some of the properties that will change? If I heat this metal rod, its length will increase. If you heat a given quantity of water, its volume will increase. Have you ever seen that happen? If you fill a container up to the brim and heat it, as it begins to warm up, as it begins to heat, the water will expand and overflow. Try it if you don't believe me. So heating a substance will increase its volume, and you can use that property to measure temperature. Why? Because in most cases, the increase in volume is proportional to the increase in temperature. So most substances expand when heated, and the increase in volume is very nearly proportional to the change in temperature. Therefore, an increase in volume of a substance can be used to measure temperature, and that is what we do in thermometers. Mercury or alcohol in glass thermometers actually make use of that property. Alright, now here I have a mercury thermometer and an alcohol thermometer, and let me see if I can show. I'm sure most of you have seen thermometers, but let me take a minute to show you these two thermometers. An alcohol thermometer that you see in red and a mercury thermometer on the right. Well, you will see it on the left. So on your left is the mercury thermometer, and on the right is the alcohol thermometer. You can see the alcohol thermometer is much easier to read because you can color alcohol. And this mercury thermometer is very faulty. It has actually broken into pieces. Now, when you supply heat to the bulb of the thermometer, the volume of the mercury or alcohol increases, and you can see the mercury level will rise. And the rise in level can be measured, taken as a direct measure of the temperature. Now see how the level goes up when I dip the thermometer in a beaker of water. You can see the level is going up. The increase in volume is proportional to the increase in temperature, and this is how we will measure temperature. Let's now talk about the different scales of temperature that